At our last video, I introduced you P and N type semiconductors. If you watched that video, I think right now you can produce different kind of semiconductors because you know how to produce them. If you didn't watch my last video, I recommend you to watch the previous videos in this playlist before you start to watch this video, because I started to talk from basics and we came until now. Now in this video I will explain you what is happening when you connect P and N type semiconductors together. The magic starts here. When you connect different kind of semiconductors, you are producing different kind of electronic components. For example, diodes, transistors are produced like that. You are only taking P and N type semiconductors and you are connecting them together. In different arrangements, you are going to have different kind of electronic component. In this video, I will explain everything on PN type diode because it is the basic one. It is the most basic. Only you are taking one P and one N type semiconductor. When you connect them here like that, it is called diode. Diode only can let current flow in one direction. Here P type is called anode. Here it is called cathode. Our conventional current should flow from anode to cathode in this direction. The electrons will flow opposite of our conventional current. Here it is the electron flow. In the last video I said you in P type there are holes. They are going to act like positive charge because absence of electrons, and here electrons, they are negative charge. Normally positive charge is here, negative charge is here. The electrons should flow towards to positive charge. However, something is happening in this field, in this region. Because of these electrons, some of these electrons will jump here. This part will be negatively charged, and the absence of these electrons here will create holes, so positive charge. And this small field is called barrier voltage. It is a junction, and in this junction there is a barrier voltage. Barrier voltage. You should exceed this barrier voltage in order to have current, because this barrier voltage will hold these electrons, and these electrons will not flow towards to P type. There will be no current flow until we connect from outside a voltage source, this diode. This barrier voltage is around 0.7 volt in silicon. If this semiconductor is made of silicon atom, it is 0.7 volt, around that. If it is made of germanium, it is 0.3 volt for germanium. Now I think you understood the barrier voltage, and now it is time to talk about biasing. Biasing means you are connecting voltage from outside. You are giving source. You are connecting a source. And if you connect your source in this arrangement, the positive side will come to P type. The P type will be positively charged with regard to N type. Here, if it is positive 1, suppose it is positive 1, and here 0. How it can be possible? If you connect it like that, P type, N type, if you take it like that, here a voltage source which is 1 volt. So what will happen? P type will be more than N type, around 1 volt. And 1 volt is bigger than this barrier voltage. If we suppose it is made of silicon, the barrier voltage 0.7 volts. So this positive charge will be able to draw these electrons because it is bigger than this field. The electrons will start to flow, and this barrier voltage will be destroyed. So what will happen? It is called forward biasing. Forward biasing means we connect it to have current. But if we connect it like that, I explained the forward biasing in this page. I have a new page because this page is full of drawing. Now I will connect it in reverse direction. It is called reverse biasing. If p-type here, n-type here holds, there is a barrier here which is 0.7 volt electrons, and I connect it like that. Here voltage source, positive side n-type, and say it is 5 volts. Now what will happen? This positive side will draw more electrons from here, and n-type will be positively charged. So what we have made here, we expanded this region, and the electrons can't flow because of this region. But when you connect 100 volt, this diode will be destroyed. There will be no any barrier or anything, and you can't use this diode again because you destroyed it. This configuration is called reverse biasing. Now let's wrap up what we have learned in this video in a clean page. When you connect P and N type together, there is a field here. It is called junction. In this junction there is a electrical field, barrier voltage, P and N. For silicon it is 0.7, for germanium it is 0.3. And if you connect positive side here, this arrangement is called forward bias, and in forward bias there is current. When you connect them in this way, negative side here, positive side here, P, N, there will be no current. Also, before I end this video, I want to mention something. Suppose we connect positive side here, negative side here, but it is only 0.5 volt, but here our barrier voltage is 0.7 because these semiconductors are made of silicons. So we didn't exceed this 0.7 volt. This electric field will beat our source, so there will be no current flow. To have current, we need to exceed this value. I think in this video you understand the junction, barrier voltage, forward biasing and reverse biasing. I prepared you for transistors. Now it is easy for you to understand transistors after you understood this concept. You understand this concept. In the next video I will start to talk about transistors, and you will understand them better. Now I will end this video. See you in the next